All right, so again, welcome noon to 1, Thursday, April 4th. This is session 11, and it is our review for exam 2. So just a note here, we have, let's see, WebWork 12, Discussion Board 5, and Quiz 5 all due tomorrow, and then all the assignments, if they haven't been done, if they're late or whatever, due by April 13th. And then the financial project due April 13th, and your exam needs to be completed by April 13th. I would recommend completing your exam before our next class session, and that is because on our next class session, we're starting the new material, and don't want you to be confused or have that in your head when you're trying to get your exam completed. All right, so that's where we're going with that. So exam is already open, and I don't know if anyone from this class and it'll be open until don't schedule it for April 13th if your testing center isn't open that day. That's a Saturday. But if you haven't scheduled your exam at this point, I can say good luck getting it scheduled. You might not be able to. If you are not taking your exam at a testing center, then you need to let me know that right away, because I do not have this exam set up in ProctorU because I haven't had any requests at this point. Okay. So I have this practice exam pulled up, and here it is. And so what I want to do is just take some time and answer questions about any of these problems that are on this paper review. Now, again, this paper review is not required, and I provided the answer key also online for you. But I will go through the problems you want me to go through. And yes, I will have it set up in ProctorU. I will do that after class. All right. So any other questions before we get started? Oh, by the way, the testing centers will have your formula sheet available, so they'll have a copy of it for you. And if you're going to do it if you're going to take your test through ProctorU, you'll have to provide your own, but it cannot have any writing on it. So it needs to be pure, not written on the two-sided answer sheet. Okay, or not two-sided answer sheet, the two-sided formula sheet, pardon me. Okay, and you won't be able to have any other papers with you except blank scratch paper. So blank scratch paper and the formula sheet will be the only thing you can have if you're going to do it on ProctorU. All right, so if you get to your testing center and they don't offer you the formula sheet, make sure you ask for it. They should automatically give it to you, but ask just in case. So I'm looking at, there are 20 questions on this paper review. And so let's just go through whichever ones you need. So the first question here, number 2, it's asking us to find the absolute and relative change. So remember, the absolute change is new minus old. So in this case, it would just be the 52.23 minus 49.48. And then you would get the answer. So Brian, downloading the formula sheet? I don't know. I would have to check. There should be one available in your Canvas course. I'll put a note here to check. But it's on page 235 and 236 in your book. So I don't know if all the pages in your book are available in your course for sure. But it's page 235 and 236. All right, so the relative change then. Okay, the relative change is whatever that answer is from part A divided by the old. So it's like this, it's new minus old. All of that divided by the old. So the answer from part A was, thank you, Brian, 275. So for part B, we're going to do 275 divided by the old amount, which was 49.48. And now we'll get a decimal 0.0556. So with the relative change, remember we can change that to a percent. So this will be 5.56%. And then we can answer our question in part C. We could say the price of Easter dinner, the average price of Easter dinner increased 5.56% from 2013 to 2014. That would be our sentence explaining the relative change. So describing absolute and relative, we could say the price of Easter dinner went up $2.75 from 2013 to 14, and that represents a 5.56% increase. Not rounded. Help me out, Brian. Be a little more specific for me. Oh, yeah, 5.6 would be fine too. All right, so the next question here, it says, it looks like it's another relative change. So this one doesn't tell us, though, which is the one we should be starting with and which one we are ending with. So let me show you both. So if we're using Parkview as the new and Lutheran as the old, we would do the 7660 minus 5142. And what is that? 2518. Oops. And then we would take 2518 divided by the old, the 5142. And so if we were doing the relative change of starting with Lutheran, ending with Parkview, so it's like how much more is Parkview, then we would have to do it this way, and that's 0.49 or 49%. So we would say that Parkview has 49% more patients than Lutheran. Now, if we were doing it the other way, do you think Lutheran has 49% fewer patients than Parkview? What do you think? Parkview has 49% more patients than Lutheran. Does Lutheran have 49% less patients than Parkview? And the answer is no, right? Because we're going to divide by a different number. So this time, if we subtract, we're doing 5142 minus 7660, and we get negative 2518. Then we're going to take the negative 2518 and we're dividing it now by 7660 because Parkview is the old number in this case. And that decimal, negative 0.329, I think. So we could write two sentences. One would be Parkview has 49% more patients than Lutheran, or we could say Lutheran has 32.9% fewer patients than Parkview. We wouldn't say negative 32.9% fewer, we would just say 32.9% fewer. So the negative indicates fewer or less than in this case. So let's take a minute and why don't you guys try number 3. I'm going to give you a minute to do that. It says the bill was $26.75 after tax with a 7% tax rate. What was the original price? So do that. And then when you're done, throw a hand raise up. Don't put the answer in the chat box yet. All right, so I see a few of you are done. So what did you come up with for an original price? All right, so Megan got $25 and Caitlin got $25. Make sure you put decimal places when you're dealing with dollars and cents. Oh, by the way, when I was looking at your Excel homework that you turned in, a lot of you had these, this chart for the credit card, and you had decimals like you had something like 2897.23, and you just had a whole bunch of decimals in there. Well, that's truly not correct. If you had that in Excel, you should have hit the dollar feature, so that would be 23 or 2897.24. So when you have a number like that in Excel, just click this dollar symbol right up here and it'll change it. So if you had 2398 point and you had all that on there as your answer, click that little guy there and it'll change it to dollars and cents, so that your table that you're using in Excel matches what you're asked about in the question. So like in this one, you're going to make sure you want to make sure all these are, oops, not the bottom one, but all those, you want to make sure they're dollars and cents. Well, every Excel assignment we've done so far, I've gone over how to do it in class, and it's in the recordings. And then you also have a help button in your Canvas course, and there are Excel help videos in there. And I'm always available if you have a question, like you have a specific question, email me and say, hey, are you available to help me? And I'll say yes, and I'll schedule a webinar like this where just the two of us can meet. That's for anybody, okay? Oops. All right, so that's just a little tidbit for the dollars and cents with Excel. Just click that little dollar sign button at the top, and it'll make sure all of your answers are in the correct format if you're dealing with dollars and cents. All right, so on number 3, there are 2 ways really that we could do it. And remember, it was 1 plus the percent as a decimal times the old. Whoops. So that's one way, or we could use a proportion. So let me do it this way with the equation first. So the new amount was the 2675, and then 1 plus the percent is 7%, so it's 0.07 times the old value. And so really what we're doing is we're doing 2675 divided by 1.07, and you get $25. So let me show you how to do it with a proportion. So remember, proportions we set up, we have 100. So the original price we don't know, that's the 100%. With tax, the price is 107%, and so the 2675 would go up here. And so what we're going to do is multiply these two together and then divide by the other number. And we get the same result, $25. So 2 ways to handle that. And then we still have these are the same. The next, I think, 3 questions are still the same idea. So number 4 is 5,800 students in 2012. That number is down 10.7% from 2011. So we have the new value. We're trying to find the old value, the 2011 value. So here again, we have 5,800. Equals, and then 1. Now, since it was down 10.7%, we're going to subtract 0.107. So really, we're doing 5,800 divided by, let's see, that's going to be 0.893. And so since this enrollment now is lower than the 2011, you should know that the 2011 value should be higher. So your answer should be more than 5,800. And I think in this case, 64.95 or 64.96. Let's see. So 64.95, yeah. Okay. So that's one way to do it. And then again, we have the proportions. We could have done 5,800 is, let's see, that's going to be 89.3%. And then we're trying to find the 100%. So that's how we would set that up if we were doing a proportion. So number 5, same idea. The original price is $249. It's marked down 20%. What's the new price? So we're trying to find the new price in this case. So 1 minus 0.2, since it's marked down 20%, times 249. So that would be 0.8 times 249, which is $199.20. So as a proportion, we would do that one like this. We'd say 249 is the 100%. We want to know what the 80% is. And so multiply these two diagonally and divide by 100. So number 6, I'm not going to write all this out, but let's just talk about it. So can someone describe what's going on here? It says the gift shop, everyone at the gift shop has been given a 10% pay cut with a promise of a 10% pay raise later. Explain quantitatively why this is or is not a good deal for the employees. This is a question we've talked about on a few occasions, actually. So go ahead and help us out with that. So I want to explain that. And again, if you're going to use the voice, don't everybody talk at once because we won't be able to figure out what you're saying. That was a joke, by the way. All right, so both answers in the chat box are correct, but they're not quantitative. So quantitatively means we've got to add some values to our answer. So you're both correct, but you have to, whoops, we want to get a quantitative answer. So you want to provide some numerical evidence. Yeah, since you don't know this already, you can just make it up. Let's say start with $100. So if they get a 10% decrease, they're going to get $90. Now, oops, increase the $90 10%, which is $9, right? Yeah, Anna, that's a good description there too. $10 an hour decreased 10% is $9 an hour, and then increasing that by 10% gives them $9.90 an hour, so they're not back up to their $10 that they started at. Very good. All right, so those elements. Number 7. Now, let's see. Will you have one? You know what, Caitlin? I cannot tell you, but always expect the unexpected. That's all I can say. Be prepared. All right. So on number 7, this is like a question or several questions you guys had on your Excel and in your homework and quiz. And number C is the one I want to focus on. Actually, number C and letter C and letter D, because that's where I think most of the difficulty was. So let's look at this. Here's the trend line, 178.09x minus 353,194. And I want to point out a couple of things here. First thing I want to point out is that this number right here does not match this first dot. Notice it's at 1854, not negative 353,194. And when those two values don't match, you're going to actually put in the year in for the x. If those two numbers do match, you're going to use the number of spaces past the beginning one. So if those matched the 1994, we would use 2 instead of 1994. So since these two values, the b and the y-intercept, don't match, we're going to put the actual year in. And you can see that with this ordered pair. If you look at this ordered pair right here, whoops, let me put it back. You see the actual year is the x value. That tells us that we're going to put the year in for the x. So it says use the trendline equation to estimate enrollment for 2004. So that means we're going to say the enrollment y equals 178.09 times 2004, and then minus that 353,194. And we're going to get an enrollment, and we want this to the nearest student because you can't have a part of a student enrolled. So tossing that in the calculator gives us 3,698, just like Megan has there. So 3,698 students. And so it says, how does this compare to the actual value? So we want to write a sentence here, and we don't want to just say it's higher. Okay, we want to say the model, oh my gosh, gives a value, and then let's subtract those. Let's see, 843. So we are nearing the end of the course here, and so you should be able to write these sentences now. What this is called quantitative reasoning. So you should be able to quantify your answers now. Don't just give a basic answer. Give something that gives a little bit of meaning here. The model gives a value 843 students higher than the actual. And then interpret the meaning of the slope of the trend line. So it's asking us, what does this value right here mean? Okay. It's not asking us to define what a slope is. It's asking us specifically for this situation, what does that value mean? And so it means that the enrollment increased by about 178 students on average. And then let's say each year from 1992 to 2010. So that would be how we interpret the meaning of the slope in that case. So notice how I used enrollment and I used year in my description. That's an important idea. And then letter D says classify the correlation as weak, moderate, or strong. So this correlation, it looks pretty moderate. It's not, I mean, in this ending area from 2003 to 2010, those dots aren't super close to the trend line. So we could say that, let's see, and it's positive because it's increasing, so make a note of that. It's positive. There's a moderate positive correlation between years and enrollment. That would be how we would classify that with a sentence rather than just a single word. It's a moderate positive correlation, and what's being correlated? The years and the enrollment. And then another question that was missed a bit on the quiz was, should we use this model to predict headcounts for 2020? Why or why not? And the correct answer is the model should not be used to predict headcounts for 2020 because 2020 is outside the scope of the model. And that's the important idea, is the range of the model is only from 1992 to 2010. So 2020 is outside the scope of the model, so we cannot use the model to describe any values or enrollments for 2020. All right, so we got to move along a little bit quicker. You get through all of these if you want to. So number 8 wants us to set up a linear model. And remember, the linear model is y equals mx plus b, where m is the slope and b is the y-intercept. And so the slope is the rate of change, and the y-intercept is the starting amount. So in this case, y equals, what do you think? The slope, the rate of change. Well, whenever you see per, that's indicating that's where the change is. It's $5.25 for each soda, so for each x. And then the starting amount is the entrance fee. You only pay that one time. So there's the model. So the variables, y represents the total cost, x represents the number of sodas that you purchase. X is the independent variable, and y is the dependent variable. And then how much can you drink for 25 bucks? So what you could do is you could say 25 equals 4.25x plus 10, and you can solve that equation. The way we do that is we do 25 minus 10, and then take that divided by 425. Another way we could do it is we could start off with our cost, $10, and then we could add the cost of each soda. So add 425, and then add another soda, and then add another soda, and then add another soda. Oh, too much. So it looks like they can purchase 1, 2, 3. So a couple different ways to do that. And it doesn't matter to me which way you do it, as long as you show your work and you have the right answer, right? So the answer was yes on the review questions for prediction life expectancy. The like the letter E, Bittul. On the life expectancy, I think it was outside the scope of the model, so it should have been It should have been no. If it was the same, if it was like letter E. All right, so number 9, this is the same idea, except it's one extra step. On number 9, we have to actually find out what the slope is. Okay, so I see what you're saying, but however, even though there's all this data, something could happen, something drastically could happen after those 115 years, and maybe maybe in that area there's a tsunami, or maybe there's some disease that comes through, and so we can't make that correlation outside of whatever the model has, because there's so many factors involved. And because it's a correlation and that isn't a causation, we can't say that was always going to happen. So that's why anytime it's outside of the scope of the model, we're going to say, no, we cannot make the prediction outside the scope of the model, because we don't know what happens, even though there's this long history. All right, does that help? Okay, good. So let's look at this next one. This next one wants us to find the slope. Okay, so we have the year, which is the X, and we have the enrollment, which is the Y. So we're going to take the new minus the old. We're going to find the absolute change of each one. So we're going to take 5209. Whoops. We're going to take 5209. Oh my goodness, I don't know why my screen is doing this. 5209 minus 3210. So that's going to give us the change in the enrollment, and then we have to divide that by the change in years. So that is 1,999. And then we have 2010 minus 2,000 is 10 years. So the slope is going to be dividing these two. So then when we write our linear model, we're going to do this again, y equals, and then the slope, which we just calculated, times x, plus the original amount, which was 3210, and we must say that x is the number of years since 2000, because now we're defining the y-intercept, that b number, as our starting position at year 0. And then it wants us to predict for 2013. So here, we're going to do that 199.9 times, now again, we're not putting the actual year, we're putting the numbers of years since 2000, so 13, plus that 3210. And we need the nearest whole number. So it looks like 5,809 students. Now, number 10 is a linear model also, but it's a little bit different, because here we want to know, okay, the profit or loss. So we're selling an alpaca for $200 each, so each indicates that's going to be our slope. And then this is the starting amount. If we spent it, though, what does that mean about the $10,000? So the $200 is coming in positive. So what do you think about that $10,000 that we had to spend? Yeah, thank you, Megan. We have to subtract it because it's money that's going out. It's negative. So the amount, the profit or loss, that's our Y, is $200 times the number of alpacas we sell, minus that $10,000 that we had to pay up front. So we want to know, how much would we have if we sold 24 alpacas? And so 10,000 minus 4,800, 5,200, yep. So we have exactly, thank you, Megan, for putting that in there, a $5,200 loss. That's what we would have. And so the next one wants to know how many alpacas do we have to sell to break even? That means we want this to be 0. We want the y to be 0. So we could just type it in there, 0 equals 200x minus 10,000. Or we could just take 10,000 divided by 200, because it's like $10,000 was our startup, divided by $200 for each alpaca. And then it'll tell us that we have to sell 50 alpacas. Okay, so that's the linear equation stuff. Number 11 is about the exponential model. So I'm just going to remind you, I'm just going to type in here, remind you how we get these values. So to get the absolute change, we're going to take the current value minus the previous one. To get the relative change, I better put the result in here too. See how much that is. To get the relative change, we're going to take that and divide it by the previous value. And as a matter of fact, all of these end up with 0.65 as the relative change, just so you can make a note of that. And then I'll put the other values in just so you have them. So remember when we talked about this, when the relative change was the same every time, that indicated an exponential model. When the absolute change is the same every time, that indicates a linear model. So we can see that this is not a linear model because those values are all different. And so it wants us to write an equation. So the equation was the amount, equals, and it's the starting amount, I'm just going to call it B, times 1 plus the percent, and it could be plus or minus, right? If it's 0.65, it's a positive. If it were negative 0.65, it would be 1 minus that. And then it's to the time power. So the equation for this model would be A equals the starting amount, that was 21.7, times 1 plus 0.65 to the t power. We could also write it as 21.7 and then just put 1.65 to the t power. Or we could use y for the a and x for the t. And then use it to predict the area of bacteria after 8 minutes. So that's what it would look like. And then how many square, square millimeters? How many square millimeters would that give us? You have to be able to put that in your calculator. And then finally on this one, it wants us to know how many days or whatever it is, how many minutes will it take to get to 3,000? And so what we're going to do is we're going to put different values in for the t until this side is at least 3,000. So what I did was I tried 10, and that was too much. So then I tried putting a 9 in. That was too little, and that told me that it was between 9 and 10 minutes. All right, so any questions so far? Questions so far? The next two questions are similar. These deal with the exponential model again. So let's take a look. So here we have this teacher. Their Twitter account has 100 students and it doubles every month. What would the express number? So write the equation. So the starting amount, it doubles. So that is 1 plus 100%. So that would be 2, a growth factor of 2. And then, whoops, number. And then how many followers after 4 months? We're just going to put that in as our exponent. And we don't even need a calculator for this. Watch. This is 2 times 2 times 2 times 2. That's 2 to the 4th power. So 2, 4, 8, 16. So she would have 1,600 followers, or he. And then, all right, Brianna. So then letter C says how many months would it take to reach 1,000,000? And so here we're doing the same thing we did up above. Trying to find out the T. And so put some values in for the T. And this one, let's see, I tried 15 and it was too many. 14 was too many. Then I tried 13 and it was too few. So it was between, oh my goodness. So I got it between 14 months. So 13 didn't quite give you 1,000,000. 14 gave you more than 1,000,000. And so it's between 13 and 14 months. And then same idea on the next one. A equals the starting weight, 2.5 pounds. It's decreasing 9%, so you could do 1 minus 0.09 or 0.91. And then to the T power. And so wants to know how much it would weigh in the year 2000. So A equals 2.5, 0.91. And then the beginning year was 1983. So the year 2000 is going to be, what, 17? So to the 17th power. And I got less than 2 pounds. So remember, you have to do this part first. Or I mean, if you have a scientific calculator, you should be able to type that in just like that. Actually, you would type it in like this: 2.5 times 0.91, and then you'd hit the button that is like a y to the x button or something like that. Y to the x, and then you'd type in 17. So your button on your calculator looks like that, probably. Or you might have the caret button on your calculator. So one of those two. And you get 0.5 pounds, right? Okay, and let's see, 14. Let's see. Whoops, why is my screen missing? Let's see here. Sorry about that. So writing the model for number 16, we'll just do that real quick. The amount is the starting amount, 6,000, and then it says it's increasing at a rate of 9% per day. So it'd be 1.09, whoops. to the T, and then T is the number of days. And then let's look at this credit card one. So starting at $300, well, let me just do the interest first. So if you remember, the interest is just 300 times, and it's the interest rate as a decimal divided by 12 months because we're doing a monthly rate. So that's how you find the interest. You just take the principal times the rate, and then the time is 1. So let's see, how much is that? $4.75. So what we're going to do is we're going to do this credit card piece, and I'll walk you through it just so we can do that one more time. 300, and it's 15%. So the finance charge is going to be 300 times 0.15 divided by 12. And $3.75. The new balance is 300 plus the $3.75, and the minimum payment. Oh, whoops, missed a number there. 303.75. So the minimum payment, it says, is 2%. So that's 303.75 times 0.02, and that is $6.08. So the carryover, the new balance, is going to be the 303.75 minus the minimum payment. And then we'd start it all over again. So we do 297.67 times 0.15 divided by 12, 372, and then we're going to have that balance plus the 372. That gets the new amount. $301.39, and then we're going to do 301.39 times 0.02 to get the new minimum payment. And then to get the next value, we take the 301.39 minus the minimum payment, and that gets us the new balance. All right, so I guess we have 4 problems left. See how fast we can do these and answer any questions that you have. So this one here, it says you have $1,000 invested. We want to know how much interest if it's compounded annually. So if you look at your formula sheet on 236, this is the one that says balance equals principal times 1 plus the rate times the time power, because this is just a straight principal rate time power because it's compounded annually, which means 1 time a year. So that one, oops, I'm going to not capitalize all this. The balance equals the principal, that's the amount that you put in, and then the rate, 1 plus the rate, so 1 plus 0.04 or 1.04 to the 2 power. And it is 1081.60. Thank you, Megan. So let's see. The next question says, what about if it's compounded monthly? So now we need the formula below that one. Whoops. So now we have the principal times 1 plus, and then we have this fraction. We have the rate divided by, well, this says monthly, so how many months are in a year? Everybody should be on that answer. 12. Now on this one, we have a different type of power too. So this one we have 12 times 2 years. So it's the number of compoundings each year times number of years. So this number 12 is the same as that one. Then we can find that value, and it's a little bit more. Remember, the number of compoundings increases the amount. So 1083 and 14 cents. And then the next one says, what if it's daily? Then I'll just do it up here. So if it were daily, we'd have the 1000, 1 plus, now we're going to do 0.04 divided by how many days are in a year? 365. And then that has to be in our power also, 365 times the number of years. And then that's going to be a little bit more. And I think when I did, I got 28 cents on there. So that's part C. So see how the number of compoundings goes in 2 spots each time. And then remember, if it's annually, you would just be dividing by 1 and putting a 1 right there. So you could use the same formula. It'd just be a 1 in those 2 spots if it were annually. So 18. So this next 3 involves the PMT, the PV, and the FV functions from Excel. So if you want to calculate the payment, that's the PMT function. Remember, so in your exam you'll be asked, what formula would you put in? Don't forget the equal sign. So PMT, and then it's the rate divided by 12 because it's monthly for a mortgage payment. 12 times the number of years, and then negative of the amount you're borrowing. So that's what we would put into Excel. And if we did that, we would get out 633.36. So the question is, how much will they pay over the life of the loan? And so we just take the payment times how many payments did they make? Well, 12 a year times 30 years. We gotta take a minute and multiply that. And then it wants to know how much will be paid in interest. So the amount paid in interest is that amount that you paid altogether minus the amount that you borrowed. So 228,009.60 minus the amount you borrowed. And it looks like that much there. Okay. All right, number 19 and 20, wrapping this up. So this one says that this Johnny has $750 that he pays in rent. He knows if he buys a house, he's going to have $150 in taxes and insurance each month, and wants to know what he can type into Excel to get the mortgage amount. So this time it's going to be equals PV. We're looking for the value. And then the rate, 12 times 30 years, and then negative 750 minus 150 is $600 that he would have available. That's what we would type in. And the last question is about the investments, and that's the equals FV. And then same idea, the interest rate divided by 12, and then 12 times the number of years, and then negative the amount that's getting put in. And then this question is like that previous one about the interest. If he was putting in $100 a month, 12 times a year for 20 years, that would be $24,000. And so we want to know how much would the interest be. It would be the amount that he had in the end, 42,311.18, minus that $24,000 that he put in, or she put in. And let's see what that is. A little over $18,000.